Okay, we get the data from the iris. Okay, can you see this one? Boleh? Okay, so when we type the iris data, so we have all this data lah. Okay, so basically we have 4 columns, the attribute and also the species. So we have 3 species, Virginica, versicolor, and also Satosa. Okay, so that is our data that we want to model. So what happened here is that I will extract only column number 1, 3, and 5. So I will now only have, maybe zoom first, view in. So iris sub. So the good thing about this one, it will help you to type the correct command lah. Okay, so this is what we get lah. So we have the sepal length, petal length, and also this species. So this is the label that we want to learn. Okay, and then after that we will because in this one for each column the name is quite lengthy, so we want to rename the column name, so we can use the name here. So basically we say I will change the name to sepal, petal, and species. So if I look at this one, so I will have 3 columns with different name lah. Okay, so can you see this one? Black. Can you see the R Studio? No? Yes? Boleh kan? Okay. And then I will load this one. The library for the graph plotting. I just want to look at the content of the data that we have. So this is the graph that we have. By executing the command. Okay, so what we want to do is we want to draw a line here lah. Okay, so we have this function including distance used to find the distance, and also we have this function that will find the that will return some other missing value or some value here. Okay, so this function is basically getting the x value and also the weightage and also the bias. So what happens is that it will return if the distance is less than 0 will be -1, and it will return +1. So it will determine whether they are belong to class negative or positive. Okay, and then this function will Perceptron will adjust the weight that we have. Okay, so since for this function that we have, we need to have input x and also the y. So we need to extract the x from the iris sub, and also the y. So since we are looking at two classes classification, so whenever the iris subspecies equal to setosa, it will be plus. So the other two value will be -1. Then we will model. We call the perceptron. Oh, distant not found. Where is distant from? Oh, this one we forgot to execute this one. So this is computing the distance. Okay. Then we call the perceptron. Then we have the perceptron. Then if we want to plot them, so this is plotting. So what we have is this. Okay. So we want to draw a line here. So this one is for all the positive value. We just make it bigger. And this is all the negative one. Okay. And then we will compute the intercept here based on the bias and also based on the weightage, and also we look at the slope based on the weightage of the two variable, and we draw the line that separate them. Okay, so what we have done so far is just perform the modeling using the perceptron, and also we plotting the positive and negative classes and draw the line that we get from the model perceptron. Okay, so when we want to perform the prediction, okay, so what happened here is just drawing the line. In the second part, we are actually looking at the multi-layer perceptron. Okay, so we are looking at the same data here. Oh, data iris. Okay, let's start new one. Okay. So just now it's just a single perceptron. Now we look at the multi-layer perceptron. Okay. So first thing that we, okay, let me share. I think I lost the sharing just now. Okay. So for this one, we're looking at the data iris. So this is the um, package for the multi-layer perceptron. So we install, and then we load into memory. Okay. And we shuffle the iris data, so that if you look at your iris data now, they will be all mixed up. So we don't have all Satosa first and so on. So this command is used to shuffle your data, okay, by using the sampling. And then we will separate the input and the label. So this one we are taking column number 1 up to number 4 as your input, and your label will be stored in this variable, the target. So meaning that for the iris values here, I'm taking all the all the rows, and I will only take column number 1 up to 4. For the iris target, I will take all the row, and I will only focus on column 5. Okay. So now I'm splitting my data into training and testing, and then I normalize the value what I have in my data, and then this is the model that I want to use. Okay, and when I look at the summary, so this is the summary. So I have 4 input here. I have 5 hidden neuron, and this is my output. Okay, so this is the weightage that we are using. Okay, and if we look at the matrix, this is the matrix that we have. Okay, so this is the weight that we are using to all the hidden connection. So if we look at we wanted to look at the error that we have here. So this is oh, figure too large. My graph is too. Okay, so we have this one. And when we perform the prediction using the input test, and when we want to plot the graph, so this is what we get. So the red one is the testing one, the black one is the during the training. Okay. So if we type the confusion metric for the training, so we get 1. Okay. In the slide we have 2. Okay, 2 and 3, but in here we have 1 and 3. So notice that every time you perform modeling for the perceptron, the weightage are different. So you will not get the same prediction. That's why in experiment you should be running more than 20 times. Okay. So for this one, you notice that during the test there are no error here, but in the slide we have 2. Okay. Okay. I think the rest is okay lah. So um, so for this short session on practical on perceptron, um, it depends on your number of attributes and what type of attribute you have. In this example, all your input are in numerical format, and for your output will be in categorical format. Okay. Okay. Any question? No. Okay. Thank you. Let